Well, welcome back to the seventh and final lecture of the series. What I want to do today is follow through on themes from last week, but at the same time remind you of some of the issues we've discussed in earlier lectures and hopefully bring us to some sort of temporary closure. I say temporary because I think the ideas that have been developed here are ones that we can build on in the future to come up with new insights. Anyway, what we did last time was, in some sense, conduct a conversation between Juhani Ballasma, thinking about the thinking hand as an architect and a phenomenologist, and my consideration of the hand in terms of the evolution of what I call the language-ready brain, by which I mean a brain that in its initial structure doesn't explicitly support language, but as humans developed an appropriate culture, then they could provide a way of using that mechanism to have language. And I developed this as a neuroscientist, Juhani as an architect. So how the hand helped the brain get language was a theme last time, and so today I want to talk about drawing and of course look at its role in architecture. So I think it's relevant to bring into the discussion a man named Merlin Donald, who wrote a book called Origins of the Modern Mind. And what he first observes is consistent with the story that I gave you last time. Modern humans appear to have reached their present form, well, I think longer ago, but certainly by 45,000 years ago. And the claim he makes is all modern humans have a fully developed speech capacity as well as complex oral cultures. So we gave a story of how we might have got to that stage of having the ability not only to sign and gesture but also to speak and to build culture on that basis. Now, what's very interesting, I think, is that Merlin Donald postulates a crucial further change, which is cultural rather than biological, namely the development of external memory. So the idea is that by being able to make markings or in other ways create external reminders, thus increasing our memory capacity, we could build a much richer culture than would otherwise have been possible. So his hypothesis is this transition started in the Upper Paleolithic with the invention of the permanent visual symbols and is still underway. So the issue I'm raising as part of our discussion today is the language-ready brain also drawing-ready? In other words, once we understand from last time something of what it was about the way the brain had evolved that allowed humans to develop an oral culture, a language-based culture, were they also ready to develop a culture based on drawing? And of course, how did those two interact? So let's just go back to our famous cup. Well, actually, we haven't seen this cup before, but the idea is what must be added to a brain that can lift and drink from a cup, that's sort of our evolutionary precursor, to get a brain that can draw the cup. What experience of a person with such a brain yields a capacity for drawing? And to preview some of the later arguments, the notion will be, okay, with the real cup, I can trace contours in 3 dimensions, and so the breakthrough is to go from this tracing of contours in 3 dimensions to the tracing of contours on a 2-dimensional surface. So that requires 2 things: the cognitive transformation from 3D to 2D, but also the development of a technology, maybe a burnt stick on a cave wall, or some other technology for transferring that 2D contour into some sort of record that will be there later to remind us about properties of objects or to provide a basis for our oral discussion of such objects. So let me just take you back to week 2 for a moment and our discussion of Peter Zumthor, who talked about memory and imagination and about construction. So memory and imagination. When I design, I frequently find myself sinking into old, half-forgotten memories, yet at the same time, I know that all is new. So the idea is I may have had a visual or multisensory experience, And what we tried to emphasize was that that perception is itself an assemblage of different aspects. I recognize the cup, I recognize the saucer, I recognize the table, and now seeing them in a particular configuration, I'm able to put those pieces together to constitute my perception of that situation. And then imagination, the suggestion is now, instead of having to dispose those memories in relation to the current visual frame, I can now pull different pieces of memory together, bind them together to come up with a whole new breakthrough in visual or other sensory imagination, or of course, as we've said, in terms of pathways to action. Then construction, he emphasizes, is the art of making a meaningful whole out of many parts. So the suggestion is that maybe drawing can be seen in this perspective then as a bridge between imagination and constructing. So we're beginning to think through the design of a building. We begin to make sketches of what one imagines that might both create atmosphere, but also the affordances on the one hand, and the construction details on the other. So there's a sort of figure of speech here on the one hand, and on the other, and perhaps that really is, in some sense, a description of what's going on, that we can imagine the hand both producing the drawing. Our imagination yields to the motion of the hand in the drawing, but at the same time, we're imagining the work of the builder who is constructing the building. And each of these processes, on the one hand and the other hand, together constitute the process whereby the detailed plan of the building finally emerges. Okay, so but our thinking here, let's not only talk about thinking about painting generally, some specific examples, and the time we're thinking about what's going on as we perceive these examples, and what about the inverse? What was going on as the artist or the painter or the sketcher produced those visual stimuli to which we can react in some way or another. So to start with, let's just consider this contrast between this drawing, where the idea is that the artist had in front of him three hands, or one presumes one hand, three occasions, and was drawing on paper an attempt to capture those three dimensions, what was going on there. And on the other hand, we have Frank Gehry's sketch, which a few of you may recognize, but many of you won't. But somehow that captured something of his imagination in the evolution of that particular building. So let's look at those two examples in more detail. So first, Albrecht Dürer's drawing from way back in 1490, a study of three hands. And what is interesting for us, perhaps, is that we do get literally, on the one hand, we have the left hand in his case, because he was right-handed, as the model, and then the right hand, the other hand, is looking at that and transferring it to the paper. And we already begin to note that this is rather sophisticated, in the sense that not only is there the recognition of contour, but he's translating the what he sees of the three-dimensional shape into patterns of shading that allow us to recognize that. So we're seeing both the recognition of contour and the recognition of three-dimensional form turn into certain conventions, which then Dürer brilliantly exploits to give us this study of the hand in three different tasks, or three different postures. On the other hand, the third hand. Some of you may know the book Pnin by Vladimir Nabokov, and he said that Pnin, when the arguments got really heated, would have a third hand to advance the argument. But I digress. Here is the sketch. Here is the building, the Guggenheim Museum in Bilbao, and we can see here a preview, as it were, of the massing of structure at this end of the building, we can see here the upward sweep, although the final upward sweep is less dramatic than what is shown here, and there's sort of a vertical structure that does not appear in this final picture. So we'll return later to think about this particular relationship between this sketch and this building in more detail. But what we can say here, at least, is the idea of beginning to get a sense of how novel shapes can be configured together to yield the overall whole. So we get that notion of construction prefigured in the drawing, realized in the building, where, of course, this whole is composed of a bunch of different holes, and then with a W-H-O-L-E-S, and then, of course, much detail has to be elaborated to see how the pieces of metal and other aspects of the building, the glass, the column, and so on, are assembled to make the final form. So we'll come back to that. But here I just want to remind you of a little discourse on visual perception from week 2. The basic idea, if you recall, was to mention the work of Hubel and Wiesel, David Hubel, Torsten Wiesel, at Harvard Medical School, where they were recording from visual cortex of cats and then monkeys, and finding that in the primary visual cortex there were cells whose firing seemed to correlate best with edges, and not only with edges in the visual field, the part of the world to which that cell was most responsive, but also respond depending on what angle, what orientation that edge had. And so we can see as we begin to put edges together, we can begin to define contours. And Horace Barlow, one of the leading lights in visual neurophysiology, whom I met as a graduate when I was a graduate student in 1961, pointed out that this could explain why a caricature, this perhaps is not familiar to all the audience, but some of you will recognize this as a caricature of Alfred Hitchcock, the director of mystery films. And what Horace was saying, this explains, this abstraction away from the image to the contours could explain why a caricature could let you recognize it. And my flip comment as a graduate student was, but Horace, here's a picture of him, how can I tell you are not a caricature? And the point I made before in week 2, and I repeat now, is that in fact these levels of abstraction don't throw away the details of contour. I mean, the abstraction of contour doesn't throw away the details of color and shading and so on, but provides, if you will, a framework within which they can be elaborated. So by pulling this part of the image out and getting a contour sketch, I can then now see how the shading and the highlight on the glasses and so on fit together. So I'm now in a position to fully interpret. And what I want to add now is that we then have these multiple levels working together, this experiential aspect, and in the end, as we go on, we're not simply recognizing what the object is, in this case Horace Barlow, but we're making some emotional connection with him. And the same is true of buildings as we look at the interpretation of the building in terms of both the Gibsonian affordances, how can we move through the building or act within the building, and the emotional affordances that we've labeled with Grafero as atmosphere. So this is just to remind us that as we try to convey things about the world as painters or drawers or sketching in other ways, we're not just simply going for contour, which I emphasized when talking about the coffee cup, but we're also going for the shading, the color, the 3D that we saw with Dürer, to be able to convey atmosphere as well as function. So here's a dramatic example of atmosphere. This is J.M.W. Turner's The Slave Ship from 1840. And our first impression is the atmosphere of a vivid sunset, a stormy sea. And as such, the initial atmosphere may be quite pleasing, aesthetic, enjoying a sunset with the wind in your hair, but then you begin to look at the details. There's a ship, obviously in distress, over here, okay, so already the storm, rather than being stimulating, there's a measure of distress. So as the details accumulate, the atmosphere begins to change, as it were, and then as you pay attention, you see hands rising from the water and manacles. And over here you see a leg rising with a chain on it. And you see sea creatures closing in on this. And you then are told or realize that what is happening is this ship is concerned about the possibility of sinking. The captain has thrown the slaves overboard to lighten the load, treating them as mere property. And so now the atmosphere perhaps shifts again, so that not only do you recognize the beauty and the danger, but you also recognize with horror the cruelty of the slave trade. And so this is just a way in which, if you will, that our building up of recognition of the objects and relationships in the scene also changes the atmosphere that we get from the scene. And so the inverse process, in some sense, is Turner starts with his famous style, and using that style he conveys that layering of atmosphere that we then, in some sense, experience in reverse order. And to contrast with a near contemporary, John Constable, we see here a style of art which is much more clearly delineated. We didn't have to search to, recognize to our surprise the arms and the legs and the manacles, which changed the whole story. Perhaps we first see Salisbury Cathedral and the horse is leading this cart to the stream, and we recognize the rainbow and the trees, and we recognize that composition. But even here we see in Constable's work his famous cloudscapes, which in fact show that he is as much the master of layered atmosphere through non-objects as is Turner. And we are reminded then that in the end, capturing atmosphere or creating atmosphere in a building goes beyond the let's recognize the objects in a scene and their spatial relationship view to what is it about washes of color and texture and 3D form that persuade us to enter certain emotional states, as do sunsets and storm clouds and other natural phenomena which don't reduce to recognizing what the object is. That's a cloud, doesn't go anywhere much towards giving us this emotional impact. So in relation to this discussion of Constable, but particularly of Turner, the idea that as you pay attention, your understanding of a scene shifts dramatically, and conversely, the way what you want to understand about the scene, returning to our basic idea of the action perception cycle, we're not in general looking passively at a painting, but we are immersed in a world in which we wish to act, and so we are seeking information relevant to our current goals. But in an art context, here's this famous example from week 2. We looked at Ilya Repin's painting. He was not expected, the man returning from the Gulag unexpectedly. And what Yarbus, the Russian psychologist, noted was that depending on the task he set to people, their eye movements were quite different. Just look at the picture. Then you get these movements. What are the ages of the people? Then mainly a focus on the faces to estimate what their age is, and then what are they wearing, and then you find our attention sort of first locates where the figures are, and then up and down to get a sense of the clothing for each person. So given the image, attention helps determine what we perceive, and then in drawing and painting and sketching, choosing what we wish the viewer to attend to is one guide to creating the final product. And so that's our theme in architecture, in some sense, by providing affordances, whether Gibsonian for interaction or atmospheric for perhaps emotional feelings. We are, in some sense, hoping to direct the attention of the inhabitant or the visitor to different aspects that will create their experience within that building. So, with that, let me just come back to a particular study of what we call as the visions system, a classic study from all of 40 years ago, where we emphasized it as an artificial intelligence system for interpreting a visual scene, but at the same time said that there was something about it in the style of the brain. But when we introduced it before, we emphasized recognizing objects in visual scenes, but let's from here consider the challenge of providing scene understanding within an action-oriented framework, linking perceptual and motor schemas within a planning process. So, where, to use another jargon, visual perception and whatever other modalities are available to us, such as touch and hearing, is a process of construction of a model of the world within the action-perception cycle. We see the world not only in terms of, oh, that's interesting, that's pretty, oh, that's this and that, but we perceive it in terms of how can I act within this context, or what do I feel within this context. So here's our first slide on the vision system from week 1, and we were just pointing out that given a picture like this, the low-level processors are going to begin to say, how can I use those Hubel-Weasel type edges and build contours which allow me to break the scene into pieces. But what we also saw was that in defining a region, we can use not only the clear contours to separate it from other regions, but we can also use continuity of color, texture, or continuous change in depth to define a region. So we see here that there's a discontinuity between this color and texture and this color and texture. So that gives us the edge there, for example. So that fits back into our thinking about what the drawing and sketch must do, that it's not only in general going to follow contours of objects and get them onto the 2D plane, but it's also going to look at things like shape, from shading as a cue to 3D shape, or color, or texture as things that must be conveyed in some way in two-dimensional form. And then our second example, returning now to the perception aspect, is that having segmented the image, we have candidates for interpretation. So we talked about perceptual schemas, which can come in and do things like, well, this is sky because it's this color at the top of the image. This is the roof because it's the right shape, and it's in the right position relative to the sky, and so on and so on. So what's missing in the original vision story is we're not talking about the way in which we extract action-relevant parameters from perceptual schemas to motor schemas. So let's return to Lina Bobardi's art museum in Sao Paulo to give ourselves a sense of looking at visual perception, to emphasize that we're not looking at what is there, but we're also making decisions. So on the one hand, we can look at this very unusual construction and the way in which, in some sense, the building is constructed like a suspension bridge with these great red structures supporting the building. But we can also look at the scene in terms of having recognized the building, we now want to enter it. And so now we look firstly at the traffic to find the affordances for safely crossing the street, where we're looking not only to recognize cars, but also estimating their velocity to see whether we have safe passage to get to the center island without getting run into. And then repeating the process to get over to the opposite sidewalk, we have meanwhile been planning ahead by saying, well, how do I get into this building? And we've observed that there is an elevator here and a stairway there, so that we're both preparing a high-level plan, cross the road, walk up here, and then, as we may choose, take the elevator. While within that overall plan, we are using our visual perception to plan the details to safely cross the road, turn and get to there, and then, of course, do the normal motor routines to call and enter the elevator. And then once we've ascended to this floor and entered the main exhibition hall, we find ourselves confronted with this unusual display that Lina Bobardi developed, where the pictures are mounted on glass panels that are themselves held in these concrete blocks. And now we alternate between a contemplative mode, in which we're positioning ourselves in such a place that we can best observe what it is we wish to get from the aesthetic or other appreciation of the painting, and then we switch to the affordance mode, where we go from the aesthetic mode to how do we now choose another painting to look at and negotiate our way around the glass panels to get to the next painting, let's say this one that interests us. So this just reminds us then of the way in which we are combining the visual appreciation, what are the objects in the scene, with, as in the case of crossing the street, how are they moving in addition to what they are, and then how does that relate to our motor planning of our behavior. But our behavior may be, in some cases, this basic, if you will, Gibsonian behavior of finding affordances for locomotion, but it may also be aesthetic affordances as we choose where to stand to best appreciate a work of art. So the issue then is, how do we get from recognition to making lines and splashing color on a piece of paper or canvas? So back in week 6, I talked about pantomime of events, actions, and objects as a path to gestures and protosign. And now I'm suggesting that contours provide one bridge from objects and actions to drawing. So this was the example I talked about of we can trace the 3D contour of the saucer and the cup, but the breakthrough is, of course, they didn't have cups and saucers 45,000 years ago, but they could observe the contours of animals, and then they could get to know those contours very well when they had successfully hunted, knowing where to spear the animal to have a success of bringing the animal down, and then the act of butchering and removing the fur or the skin or what have you. So the knowledge of contours was there. The breakthrough that came much later than knowing how to use those contours for hunting, for foraging, for taking the food and exploiting it, there was the breakthrough to understanding that there were ways that the contours that came from our interaction with objects could be turned into contours on a piece of paper that captured something of the spirit or soul of that animal, let's say. And then the complementary discovery of how to use patches of color to complement those contours. And so we know that humans have been using ochre for actually well over 100,000 years. So originally they were using that to decorate the body, perhaps inspired by the bright plumage of birds, and well, perhaps in terms of the power of the sunset. But then they went from these biological mimicking of enhancements of the person to the way in which that tracing of contour could be augmented to give something of the cues that create a surface that is distinctive from other surfaces, rather than just simply given by that contour of the caricature that we talked about in discussing Horace Barlow. So I talked about last time in discussing complex imitation the idea that we can recognize another's performance as a set of familiar movements and use this recognition to repeat the performance, and suggesting this was the secret to humans' ability to transfer skill by recognizing what it was about an apparently complex performance that could be based on what the observer already knew how to do, so that over time they could build up their own version of that skill. And what I'm suggesting is that we looked last time at this as a step towards gesture and pantomime and the emergence of language, saying that a brain that had pantomime and complex imitation was language ready. And what we're now arguing is that similarly, that ability to take gestures in relation to objects in the world becomes and make that a drawing gesture as well as a communicative gesture, suggests that the language-ready brain was in fact drawing-ready. Once the technology of making contours on a cave wall or in the mud and applying patches of color were there, that cultural evolution made that available to humans, and that then became drawing was a transferable skill, and bringing the observational memory of a scene back onto canvas or paper or cave wall, well, on cave wall long before it was paper or canvas. So let me now make a connection, now that we've got some idea of this brain that can support both language and drawing, and the claim from last time that it was the, if you will, the thinking hand, or at least the brain body system of which the hand was a crucial effector, that provided the evolutionary basis for a brain that could support language and a brain that could support drawing. Let's just return to a little bit of basic anatomy. We said that to get from vision to hand, the brain had two pathways. In fact, there are many subregions involved and many detailed pathways. But at a high level, we can dichotomize the path from visual cortex to motor cortex as a parietal path going up the top and over, and that's the dorsal path, like the dorsal fin of the shark. And then there's the ventral path that goes down through the inferior part of the temporal lobe behind the temples, and then up through the prefrontal, the very front part of the frontal cortex, and then up to motor systems. And we reported on the discovery by various colleagues, I won't repeat the details, that this pathway, the what pathway, the ventral pathway, seemed to be the one that could recognize objects, their relationships, to develop plans for what behavior am I going to do? Like, am I going to pick up that mug to move it to another place, or am I going to pick up that mug so I can drink from it? And then we said, but having made the plan, the ventral cortex the ventral path had to coordinate with the dorsal path to say, okay, but what are the motor details? How do I now actually instruct the arm to move the hand to just the right place and pre-shape the hand, so that when I get there I can very quickly grab the handle or grab the rim to prepare for the next step of the planned behavior. So the question this raises is, okay, we saw the distinction between how and what in controlling the hand for a skill interacting with objects in the world. What do the distinctions mean, perhaps, in terms of drawing? Is there a sense in which we can talk of sketches which invoke the how more than the what? Maybe Jackson Pollock is an example of where the details of the movement replace this. Is there a what he intends to evoke? But let's look at a fascinating neuropsychological result. The work of Vatner et al., quoted in the book of Van Summers, we'll be coming back to in a little while. And here is somebody who had a brain lesion which led to what I'll call how-only drawings, where he seems to only be exploiting the how pathway and not the what pathway. And it turns out that a number of autistic children appear to be very skillful drawers because they have this attention driven only by the how pathway. Look what's happened here. Here's a stove. They're given as a model a stove with a rooster with a very fine tail atop that stove, and they copy it. If you look at this superficially, you think, gosh, this person's pretty good at drawing. And then you suddenly pay more attention and you see, well, it's not quite that way, because here there's a discontinuity between these lines and these lines, and there's a discontinuity between these lines and these lines, and these lines tend to get mixed up with the lines that define the legs of the stove. And you realize that the subject here is simply observing contours and trying to reproduce the 2D disposition of contours here over here, but has no understanding that this is a rooster's tail that comes all the way here, and that therefore these breaks and these breaks are unacceptable. So, although there's the illusion of skill in drawing here, this subject and many autistic children lose that crucial blending of the what and the how pathway that's successful for the interaction with the world, that can then be transferred into a knowledgeable disposition of marks on the paper to constitute a successful drawing. Which is not to deny, of course, that in later art forms, abstraction from the constraints of the reality can constitute a valid piece of art. Hand motions for sketching a specific form of embodiment transforms to the manual action of drawing, and I made that very plausible with the example, not one of our ancestors of 50,000 years ago, but the example of hands-on objects. So I even said that with animals, although you might see them in the distance and recognize them, the recognition of contours could be related very much to the hunting of the animal and the butchering of the animal. But what are the ability to draw landscapes? This would seem to rest in part on the ability to ignore the ability, yes, that's intentional, the ability to ignore the ability to scale objects. So one of the big things about visual perception is that if an object is near me, it occupies a large part of the retina. If it's further away from me, it occupies a small part of my retina. But in general, I can get a coherent three-dimensional understanding of the scene that lets me understand the object has not changed size as it moves away from me. So, in some sense, we can turn off that ability to say, how do I take something very large, a landscape, a mountain, let's say, and instead of being able to trace the contours of the mountain directly, I can sort of say, okay, as I move my hand so that it appears to trace the contours of the mountain, okay, that's what allows me to transfer the object to the page. And I like these two photographs, which in some sense make the point. So Cole Thompson takes these photographs of sand dunes and says, I've become attracted to sand dunes and their abstract resemblance to the human nude. This is my favorite from the series, The Dunes of Nude. So here he's looking at objects and in the distance, and by forgetting this issue of what is the size of it through my knowledge of moving in 3D space, but looking at it more abstractly, he can relate the forms to those of a female nude. And conversely, Ruth Bernhard in her Sand Dune Nude of 1993 goes in the other way by placing a human model in an appropriate way and lighting in the strange way. She tries to give some sense of the perception of the human form in a way that blurs the distinction between the human form and the sand dune. So this is just to give some sense of the way in which over time artists would build up their vocabulary to become able to abstract from the immediate contours of the object that their hand could trace on the object to the way of bringing the larger world onto the page or onto the cave wall, as the case may be. So with that, let me now turn to the work of Peter Van Summers. So this is a book he published, but I'm going to concentrate on a 1989, a 30-year-old article, A System for Drawing and Drawing-Related Neuropsychology, that he published in Cognitive Neuropsychology when he was a professor of psychology at Macquarie University in Sydney, Australia. He is now actively engaged as an artist rather than as an academic. But let's just take a few examples from him that will pave the way for, I think, the most interesting example for our consideration of the way in which sketching may help us. He's going to give an example from sketching from memory. What we're going to take from it are lessons about sketching from imagination. He's going to talk about, as I keep repeatedly sketching, I can help summon more and more details from my memory of an actual pre-existing object. And the notion, of course, is that if we understand those mechanisms, neuroscience can help us explore the mechanisms whereby, through imagination, we can develop more and more of an object that has not yet existed until it emerges through that process. So let's look at that. So here, Van Summers is giving us a schematic for the drawing process. So in some sense, this process, he's following David Marr's theory, but I don't think David Marr's theory necessarily applies. But this is sort of what we were covering through the visions system. The idea that we can look at a drawing of an object or a real object or an abstract pattern, and we can come up with contours and patches of color and so on. But in this discussion, Van Summers is drawing our attention to drawing, to putting lines together. And so the idea is, I don't think we have to go through this idea of reconstructing in 3 dimensions what we see. In some cases we do, in some cases we don't. The 2.5D sketch of David Marr was sort of a bas-relief type structure. So in some cases that's relevant, in some cases it isn't, as we saw in the vision system. But what he calls visual recognition units, that corresponds to our perceptual schemas. And in the ways we've described, and we'll look at his ideas on the next slide, in the ways we've described, that visual recognition of both contours and palette can drive the production of a drawing. And then what is over here is the idea of a semantic system. It is that I may look at a cup on a saucer and have a very specific delineation in mind, which I can then link as the bridge between the visual experience and the drawing of the shape and size of the cup and how it's placed on the saucer. But if I just say to you, in this case his example is bell, but I can just say to you, there's a cup on a saucer, or you can hear the sound of somebody putting their cup down on a saucer and recognize that sound, and then whether it's based on your linguistic analysis of the sound or your recognition of ambient sound more generally, you can build up a representation which lacks most of the parameters needed, and then so you have to supply those parameters to then get a visual representation, or a visuomotor, preferably, representation that can now be played out here. And let me just refer you to a little video which is very funny, but I'm not going to show it to you, so I'm just going to tell you it's funny rather than show you it's funny. But it is there was a movie that many of you know about called The March of the Penguins, and the penguins, in fact, were emperor penguins. So the French version of the movie has a title that, bringing it back into the English, is not The March of the Penguins, it's The March of the Emperors. And so Canal Plus, a French television channel, has a man and a woman at a cafeteria line, and the man is telling the woman about the movie, The March of the Emperors. And immediately she thinks of the Emperor Napoleon. And then he says there were hundreds of them, and suddenly she thinks of, rather counterintuitively, hundreds of Napoleons in a mountain landscape, and then he says they're in Antarctica, and so now these emperors are tromping across the snow. And so it continues until finally the narrator, the young man, tells her that they were exchanging eggs with each other, which she imagines in terms of them passing cartons of eggs to each other. And then he says that was after hours of making love, and at that stage her imagination shatters and she recoils, and Canal Plus gives the point of the skit, which is some movies are made to be seen and not heard. And so I ask you, or I invite you to go online and search on March of the Emperors and enjoy the video itself, where it indeed is to be seen rather than heard, to appreciate the impact. But anyway, the whole point of this is that imagination may leave a lot of details out. The cup is on the saucer. There, you can or cannot see the coffee within the cup. But now the realization of that, the shape of the cup, the size of the cup, and so many other details have to be filled in before drawing can take place. And so in some sense, imagination is operating like this, that one may be already appreciating some of the details in their 2D, 3D relationship, and others may be more vague. And so that's part of what the sketching is going to do, perhaps by providing you, you see the drawing, you see that some of the things are not as you intuited or don't quite fit your constraints, and so you fill them in again and you get a better sketch, and so the sketch elaborates, whether, as I say, this is from memory, trying to come up with an accurate drawing of something you remember, or whether it's imagination as you try to fill in the details to fit some, perhaps themselves, changing criteria for what constitutes a satisfactory sketch or design. So, for Van Summers, this drawing is what are the decisions and processes to be made, how do you chunk it to draw this part and that part, what planning is contingent, articulation and economies, motor programs. But in terms of what we said, the issue of, am I going to draw this part and then this part? Am I going to draw this part in detail before I draw this part? Am I going to draw this part in some detail, fill in some more details there? Am I going to see how they're articulated with each other? Are there ways I can put in more lines or less lines? And as I make those decisions, that's playing out over our motor schemas to begin to develop the drawing. And as we'll say, there may be one completed drawing that then provides either itself, we get out the eraser or the whiteout and elaborate it, or it may be that we put that to one side and then we repeat the process where we're using the first sketch as a model for the second sketch as a model for the third, but each time adding more detail while changing other details in the process. And what Van Summers does is redraw a diagram from Martha Farah in which she looks at the effect of brain damage on people's visual perception, and just to make us see that there is this notion of a visual buffer which in some sense mediates between encoding, as in the visual system story, what you get from the environment, and coming up with ideas that can tap your long-term visual memory to generate entries in the visual buffer that can then be used for a description of a visual scene, a copying of a visual scene, and so on. So that's the sort of general framework in which we're talking. And now we can come to the data, which I think give us some real insight to take to this notion of sketching from imagination, although, as I say, the data here are sketching a pre-existing object from memory. So ignore these two for a moment, and these are just sketches of bicycles where undergraduates at Macquarie University were asked to just draw a bicycle. As you can see, the drawings vary in quality, but also if you look at them more carefully, some of them are pretty strange. Here we have the bicycle pedals, but no chain to make use of it. Here we have the chain, but no pedals, and the chain bizarrely joins the front and the rear wheel, and so on and so on and so Here is just an example of a drawing by a person with some brain damage where the chain sort of goes off into space without even connecting with functional elements. And here's a graphic design which throws away a lot of elements because it's not trying to convey the working behavior of the bicycle, it's trying to convey some idea of the speed of a courier cycling to you. But the really interesting result from all that is that he then asked the students to look at their sketch and just improve it. Look at their sketch and improve it. So in a few minutes, from a single subject, without any instruction beyond asking him to try again, reflecting carefully about what he knew or could work out about bicycles. So we start with this sketch, fairly nice, but here's the pedal suspended in space. He comes in again. He says, oh, well, the pedal has to be connected somehow to the rest of the bicycle, and the whole point of the pedal is it drives the rear wheel. So he now has the pedal connected to the frame and connected via a chain to the rear wheel. And then he looks again, and he begins to go from lines to sketching the idea that there is a tubular structure there. He adds the spokes to the wheels. He has the sprockets so that the pedals, now made more three-dimensional in appearance, can drive the rear wheel and so on. Strangely enough, the mudguards, which figured in the second sketch, are lost in the third sketch. But, as I say, my point here is that by seeing the way in which we can consult long-term memory to use the external sketch, we're back to the virtue of external memory as we got from an early slide from Merlin Donald's evolutionary account of the origins of mind. We see here the way in which being able to stare at this provides us a way of looking at it and saying, oh, I left out how this is connected to the bike. I left out how this drives the chain. And so, yeah, maybe I should spell out how the sprockets are going to drive the chain as the pedals are turned. And so what we're suggesting is we're getting a view here working from memory to insight into how sketches may help the process of imagination by saying, okay, I'm imagining this, here are certain things, I get that down, and now I can look at that and say, okay, I understand, but I imagine that I need to do this, and I imagine I need to do that, and maybe the spatial disposition and the functional parameters or the way atmosphere is conveyed will change in the process. But so we go back to that initial inspiration that we had from quoting Zumta in terms of how he went into memory. Half-forgotten memories are pulled up, but in the end all is new. So that in here we're saying all is old. I get more and more accurate about what I already knew. In the process of sketching for an artist or for an architect, all is new as one begins to add details, not because they were already associated with this structure, but because they are associated with different structures or with pictures of different structures or imagination of what it would be like to walk through this area and so on. And so they begin to assemble themselves. So let me take a slight detour, because I've said that the structure of this building, of this lecture, is in some sense based on comparing language and drawing in terms of what the brain must do to exploit eye and hand to, in the one case, produce gesture that could then evolve into symbolic expression, and on the other hand, as we keep saying, could be used for sketching and drawing and painting. Okay, so a question that comes up, people often talk about the language of architecture. So what I want to say is there a language of drawing, painting, or architecture? And let me give a qualified answer in the following way. Firstly, just a personal reminiscence is that when I was about 10 or 11 or 12, I had a building set called a Bako set, and let me just show, and I'd totally forgotten about this until a month or two ago. But in fact, it went like this. there was a base with holes in, and in those holes you could place metal rods. And then there was an array of pieces available, such as portions of a brick wall, a red or a white. There were door pieces, there were window pieces, there were little metal bars that you could use to close things out. And as we can see from here, there was quite a diversity of pieces related to, if you like, the suburban English architecture of post-war England. And in some sense here I think we can talk about a language for building. There's a lexicon, a set of words, in this case these pieces, and then there's in some sense a grammar, a way of putting these pieces together. You have to have rods in the base that can hold the pieces, and then that provides the basic structure, and then you can add certain new pieces that will fit in with the existing structure. And so in some way I think we can use the notion of language in terms of, I start with a fixed vocabulary, what blocks are available, what words are available. I start with a set of construction rules, rules of grammar, which says I can put verbs and nouns together in this way, I can put pieces together in that way. But that doesn't quite make it for all of architecture. So language, we use the constraints of grammar, put words from the lexicon together in new ways to express new meanings built atop the prior meanings of each word. Now architecture is a design process. It goes a little bit beyond the notion of the way I use language or the way you use your language, because each design may lead to the discovery or invention of new building blocks. So it's not that you start with here's the vocabulary, the fixed vocabulary that I have at my disposal, as it might be at a particular time with a particular building technology. I can invent new ways, I can change the lexicon, and I have new forms of construction, so I can in some sense change the grammar. So there are some vague parallels. What are the building blocks? What are the rules which allow me to put them together? But here I stick with speaking comprehensible English. Here I may blow your mind, perhaps, with totally new ways of thinking about what a building is and what I can put into the building and how I can put those elements together, as we'll illustrate with Frank Gehry in a moment, as we can see perhaps even more dramatically, or at least as dramatically, in the work of Zaha Hadid. So once the building exists, though, there's a different language. There's the language of behavior. The building provides affordances, and each inhabitant may explore them to create their own meanings. So I think this is something we talked about briefly in the week we discussed atmospheres, where we talked about the notion of comparing set design for a play with the design of a building, and we said that when the set designer builds a set, makes a stage setting, the script of the play is already there, and the issue is how to provide the framework for the pre-scripted actions and speeches of the actors. Whereas when the architect designs a building, he or she provides various affordances, tries to establish various atmospheres, but then each of us can behave in different ways as we come into that building. Maybe other people around us will change the way we interact with the building, so we create our own scripts, our own meanings. So, language in the sense of putting words together with grammar to convey meaning to our friends and others. Architecture is a much more flexible, structural, three-dimensional creation of atmosphere and affordances, and then the behaviors that we can exhibit responding to the affordances of the building. So, with what I think is the last part of this talk, I want to return to Frank Gehry and the architectural sketch, and then close with some further discussion with Ioannis Ballasmar about the role of the hand. So, as we've said, this sketch was part of the development of the Guggenheim Museum in Bilbao. how did Gehry come up with this? Well, probably what happened was he looked at the site, he began to develop some ideas about what parts of the building he would have to have, and then he began to sketch what are the relative masses and some of the spatial features that he would have. So it captured in some sense a gist that would serve as a basis for further elaboration, perhaps changing some of it in the process. As we saw, this particular upsweep didn't appear to be in the final building. So in one way it functions as an aid memoir, in the sense that having come up with one sketch, then it can be stared at, and then one can change perhaps some of the shapes, or think more about the program for the building, what the galleries must be, what the public space must be, and adapt it. And it also serves for interaction, that at some stage Gehry can discuss this with other members of his firm, and what's clear, this is not very helpful as something that you could hand to somebody and say, go ahead and elaborate this design, but it can act very usefully as an anchor for discussion as Gehry shares his unfolding ideas about how different parts of the building will be married to different forms. And so we can get that interaction with others. But in fact, it turns out that other processes are also at work. But before I tell you what those are, let's look at the way in which the personal doodle becomes finally a medium of communication as we go from that original sketch to here is a more elaborate part in detail, where we see how the idea of the shapes are beginning to be elaborated, the idea that it's going to be constituted with panels is there, although the exact disposition and shape and size of those panels is not done. Here's a vent, here's the specification, only the floor is straight, vertical surfaces are curved. And it's interesting, going back to last week's discussion, that we're seeing here the sketch is already being complemented by the use of language. So we have the sketch both in terms of an aid memoir. The sketch is something that can be elaborated in great detail as we work towards the working drawings, and we can also see it as part of a social process where the drawing is combined with language to get the full means of communication. But with that, let's just look at Frank Gehry's process in more detail. This particular description is taken from the website of the Art Gallery of Ontario. Gehry's firm designed a major extension for them, and so there's a website, www.ago.net, which includes various things about the extension, but has part of that is the source for this. So their design process is based on extensive physical modeling at multiple scales, so that although until now I've been emphasizing sketching in terms of drawings on a sheet of paper, and of course going back to the cave walls, here we're talking about sketching can also be done in 3D. One can, Rem Koolhaas's firm takes pieces of blue foam and cuts them in different ways to create three-dimensional sketches of what a building will look like. The Gehry practice is more taking pieces of cardboard and bending them around and tweaking them to get 3D sketches. But anyway, the modeling can be at multiple scales, in which we're getting both the functional and formal aspects. So for example, in the case we're talking about, well, I want the public space here, I want a gallery for small works there, I want a gallery for large works there, things like that. Then rather than designing on a two-dimensional plane and extruding the model as a finished project, modeling at various scales throughout the design process keeps the architects focused on the building, so the model is not an end in itself but a representation. But notice already that the same skills we talked about in developing our notion of how we transfer 3D experience to 2D drawings, paintings, and sketches applies just as well to the ability to make models. And I suppose my little Baco building set from my early teenage years, or pre-teenage years, would be an example again of that. So Gehry and his team used block models to form massing models, multi-configurations that establish relationships between a building's functions, such as gallery, lobby, hosting, and conservation areas. Detailed context models are also complete at this stage to ensure that the building's massing is respectful to the neighborhood it inhabits. Once program needs are met from a massing perspective, the architectural and sculptural phase begins. And the catalyst for this phase is an idea or sketch that forms the basis for many small-scale gestural models, which establish working concepts and are often constructed of ephemeral materials. The critical moment comes when these gestural models are merged with the functional model. Okay, so we've got that idea of sketching. The rough sketches can be either on paper, which got us started, or can be bits of blue foam for Koolhaas, can be bits of cardboard put to each other, but eventually that has to be, the different sketches of different parts of the building have to then be elaborated responsibly to move to making sure that the functions are met, the spatial relationships are established. And so, intriguingly, Gehry's shop has methods from aerospace architecture from the physical to the finished building as follows. So, they go through this modeling process till finally they have this large, accurate 3D model. So in other words, it's a scale model where all the measurements have to be correct. And then they scan that into the computer, as shown here, to get a surface model. The shaded surface model is not so important. The important thing is that they know for each part of the model what the curvature is. Why is that important? Because they're now going to analyze that curvature to say, okay, if I've got a relatively flat piece, I can take a large titanium panel to cover it. If I've got a place of rapid curvature, I'm going to need multiple small pieces to cover that range of curvature. And then once I've got that, I have a shop drawing which will tell the contractors in great detail, this is the framework you're going to need, these are the pieces you're going to have fabricated, this is how the pieces are going to be assembled on that framework, and then eventually we get to the final building. So what's interesting here is that the development of sketches in 2D and the development of sketches, the gestural models, if you will, in 3D, proceeds on and on, but in this case, the use of computer-aided design comes very late in the piece. And so it's that issue of, can one do the sketching on the computer, or must one do the sketching either in 2D or through these gestural 3D models, and only go to the computer as a tool to get the final shop drawings together, or can one sketch right from the beginning? So let's give Juhani Ballasmaa the almost last word on this. So on page 97 of the book we discussed last time, The Thinking Hand, he says, the computer creates a distance between the maker and the object, whereas drawing by hand or building a model puts the designer in skin contact with the object or space. Very poetic language. In imagination, the object is simultaneously held in the palm of the hand and in the brain. We are inside and outside of the object at the same time. Ultimately, the object becomes an extension and part of the body. But the question, I think, that really has to be addressed, this is very poetic, but is it true? Might not a new generation raised on CAD, as it were, be able to imagine this extension as readily when using CAD? In a sense, when we draw on the computer, the motion of our hand is capturing the contour, which instead of now being marked directly on the piece of paper is being marked on the screen. But it has the disadvantage, perhaps, that it may come with the ability to add precise numbers to it, but it may also come with just a sketch. Perhaps some of you have seen David Hockney's paintings using an iPhone sketching app, and he's pretty clever in the way he can come up with blobs of color that together constitute artworks. So might not the skilled user of the computer and the mouse come up with sketches too that can embody these intuitions. So here we are. For Juhani, when I advanced this idea of, well, computer skill could lead to sketching on the computer, he said he wants to stress the role of architectural drawing as a means for the internal mental processes and communication between the architecture and his project. And he said, to quote, "This is where the importance of sketching is, not in the task of communicating already made choices to engineers, builders, and clients. Here I completely disagree with your view that the computer generation can sketch with the computer. This is a question of fundamentally different mental and embodied processes which are differently grounded in our existential reality." Well, is he correct? I certainly know that I went through a period when word processors first appeared, when I felt I needed to write out in longhand my ideas and my mathematical equations. But over the years, I've got to the point where I almost feel I'm wasting time if I write longhand, because once the words are in the computer, then I can move phrases around with facility, I can edit, I can still insert new ideas, I can change my mind and throw some stuff out or radically contradict what I first thought to be the case as I understand that something else is the case, and so on. So this is a very strong position of Juhani's. He is a very skilled architect as well as one of our leading scholars of architecture, so I'm not in a position to say he's wrong, but it's a question nonetheless. And so I close this with the issue, this could be the basis for a study in the cognitive neurosciences, which would be of great interest to architects, namely just have young architects and have them, give them an interesting task in designing a little building of some kind to meet a certain set of restrictions, perhaps with some landscape views to go with it, and just divide them randomly into two groups and have one group must sketch and sketch and sketch and sketch until they've got a satisfactory design before they touch the computer, and the other group is forbidden to set pencil to paper but must do everything on the computer. And then some good jury would look at the results and judge which, without knowing which ones were drawn on computer, which ones were drawn on paper initially, judge how good the results are, and at the same time as having some objective results. Let's say everybody had the same number of hours to work on the project. So that's sort of a suggestion of how this type of lively debate about the role of the hand, the eye and the hand in architecture, whether in terms of language or drawing or model building, how they might work together as we develop new tools to assist our work in architecture or in other fields. So with that, we come to the end of these 7 lectures. We say farewell. I've tried to give you a feel for the interaction between neuroscience and architecture by looking at 3 different things. What goes on in our brain as we experience architecture? We've talked about the Gibsonian affordances as well as atmosphere. We've talked about the action-perception cycle. We don't just perceive passively a building, we interact with the building and with others. So there's the experience of architecture. There's the neuroscience of the design process, what goes on in the head of the architect. And clearly, part of what goes on in the head of the architect is to simulate what the experience of the architecture will be. But we've suggested that if we know more about the brain, then maybe knowing the difference between how a child perceives the world and how a person with Alzheimer's disease perceives the world, and how they each engage in the action-perception cycle, and to what extent memory can grow in one case and is diminishing in the other, maybe this can factor into a knowledge of how architecture will be experienced by different populations, rather than the architect simply imagining how people like he or she would experience that. And so the drawing and language discussion has in some sense been engaged in thinking about this loop between the experience of architecture, the design of the process in architecture, and the relation between the two as we probe what the brain, hopefully connected to the body and the hand, can achieve. But I also took a detour for a while to say, well, what happens if we begin to think about smart architecture in terms of more extended interactions going beyond heating and air conditioning and so on, to the sort of even emotional interactions we saw initially in the Ada architecture, Ada, the intelligent space from 2002, and the idea that we may also have interesting discussion as we learn from the brains of different animals and these interaction infrastructures, these quotes brains of different buildings, and so enrich it. And the final comment before I leave you is this idea that my push has been to create a space which will be exciting to architects and neuroscientists both, and create interaction between these communities. So it's not just the claim, as some people in this community would make, oh, here are lessons from neuroscience, plug those in, and that will help you do architecture. That may be true, but that's not so much my burden. It's been rather to say, here are ways in which your understanding of the architectural process may be illuminated if you understand how the brain is engaged in those processes. But I also have tried to go the other way by saying that the neuroscience is not a fixed structure from which nuggets can be extracted that may be of interest to the architect. Neuroscience is a huge community of people doing many different things, and so we want to go the other way of saying, if you think outside the box of the laboratory perhaps, and look at people interacting with buildings in the world, you may come up with new challenges which can then come to neuroscientists, and in some cases it may yield very focused topics that can be taken back to the architecture. In other cases it may yield new avenues of basic research that only in the long run will feed back into this conversation between neuroscience and architecture. But in any case, I hope this has stimulated your thinking about that interaction, and I hope that in the years to come I'll learn from what you achieve as you ponder what I've been able to present to you in the last few weeks. Thank you very much.